In the cool pre-dawn hours at SpaceX's sprawling test facility in Texas, a hush settles over the landscape, just before the thunder of ignition. Here, engineers gather around screens, their faces aglow with anticipation and the blue light of data streams. The Raptor engine, a marvel of modern rocketry, sits poised atop its test stand, embodying years of relentless iteration and the quiet, stubborn hope that the next leap in technology is always within reach. As the countdown begins, one can almost feel the collective breath held, the silent promise that this engine, this intricate dance of metal, fuel, and fire will push humanity further than ever before. Across the country, in the calm hum of Tesla's assembly lines, a different kind of anticipation fills the air. Here, the future is built not with the roar of combustion but with the silent surge of electrons. Tesla's engineers move with practiced precision, assembling electric motors and battery packs, their work guided by the same spirit of innovation that fuels the rocket launches in Texas. There is a quiet symmetry in these two worlds, both driven by a desire to redefine what is possible, both shaped by the vision of a single, restless mind. It is tempting to imagine a direct bridge between these two realms, to ask if the ingenious design of SpaceX's Raptor engine might someday transform the humble electric motor at the heart of every Tesla car. After all, both companies are bound by more than their shared leadership. They are united by a culture that prizes radical thinking and the courage to challenge established norms. Yet beneath the surface, the technologies diverge in ways that are as profound as they are instructive. The Raptor engine is a testament to the power of combustion, a symphony of controlled explosions that propels steel and hope skyward. Its full-flow staged combustion cycle is a rarity in the history of rocketry, a complex choreography where every molecule of fuel and oxidizer is pressed into service, squeezed for every ounce of thrust. The engine's heart is a crucible, where methane and oxygen meet in a fiery embrace, cooled only by the ingenuity of its designers. Every gram of weight is scrutinized, every bolt and weld questioned, until only the essential remains. The result is an engine that is not only more powerful, but also lighter and more efficient, a fitting metaphor for the relentless pursuit of progress. In contrast, the electric motors that power Tesla's vehicles are studies in quiet efficiency. Where the Raptor's power is measured in the deafening roar of launch, Tesla S motors whisper their strength through the smooth acceleration of a Model 3 gliding down a city street. These motors rely on the invisible hand of magnetic fields, coaxing rotors to spin with a grace that belies the complexity beneath. The transition from the induction motors of Tesla's early days to the permanent magnet synchronous reluctance motors of today is a story of incremental refinement, each step driven by the same questions that animate the rocket engineers. How can we do more with less? How can we make the machine disappear, leaving only the experience of effortless motion? Yet, for all their differences, the stories of the Raptor engine and Tesla's electric motors are interwoven by threads of shared innovation. In both worlds, the boundaries of what is possible are stretched by advances in manufacturing, by the willingness to embrace new materials and new methods. At SpaceX, the adoption of metal 3D printing has transformed the way engines are built, allowing for shapes and structures that would be impossible with traditional techniques. Components that once required dozens of parts and countless hours of assembly now emerge fully formed from printers, their complexity hidden within their seamless exteriors. This same spirit of manufacturing innovation finds its echo in Tesla's gigacasting revolution, where massive die-cast machines produce entire sections of a car's underbody in a single elegant piece. The old paradigm of hundreds of stamped and welded parts gives way to a new simplicity, a new efficiency born of bold thinking. The lessons learned in the heat and pressure of rocket development do not remain confined to the launch pad. They seep into the design studios and assembly lines of Tesla, informing decisions about how to cool an electric motor, how to shape a chassis, how to question every assumption about what a car can be. The regenerative cooling that keeps a Raptor engine from melting under its own power finds a distant cousin in the dual-mode coolant loops, that keep Tesla S motors operating at peak efficiency. Both systems are born from the same imperative: to tame the heat that is the inevitable byproduct of power, to channel it, control it, and, where possible, put it to work. Weight, too, is a universal adversary. In spaceflight, every kilogram saved is a victory, a chance to carry more payload or travel farther. In automotive design, weight is the enemy of range and performance, a drag on efficiency that must be fought at every turn. The Raptor engine's dramatic weight reductions, achieved through the ruthless elimination of unnecessary parts and the integration of functions, mirror the philosophy behind Tesla's gigacasting approach. Both are exercises in subtraction, in finding the core of the design and stripping away everything that does not serve it. But perhaps the most profound connection between these two worlds lies not in any specific technology, but in the way problems are approached. At both SpaceX and Tesla, there is a relentless questioning of requirements, a willingness to challenge the status quo and to ask, again and again, why must it be this way? This culture of inquiry is the true engine of innovation, the force that drives both rockets and cars to new heights. It is a mindset that values simplicity, that seeks to integrate and streamline, to make the complex elegant and the expensive affordable. As the sun rises over the test stand in Texas and the assembly lines in California, one is reminded that progress is rarely a straight line. It is a process of iteration, of learning from failure and success alike, of carrying lessons from one domain into another. The Raptor engine may never find its way under the hood of a Tesla, but the spirit that shaped it, the drive to question, to simplify, to innovate, infuses every bolt and circuit of the cars that bear the Tesla name. In the end, the story of SpaceX S Raptor engine and Tesla S electric motors is a story of convergence and divergence, of parallel paths shaped by a shared vision. It is a reminder that the boundaries between industries are porous, that ideas and innovations flow across them like currents in a vast sea. The technologies may differ, but the questions remain the same. How do we go further? How do we do more with less? How do we build a future that is not just different, but better? As rockets rise and cars glide silently through city streets, the answers to these questions are written in the language of engineering, in the quiet confidence of those who refuse to accept limits. The journey from the launch pad to the highway is not a simple one, but it is guided by the same stars: curiosity, courage, and the unshakable belief that the best is yet to come.